Welcome to Science for Sleep, the channel where wonder meets rest and the universe tucks you in. Tonight, we begin a quiet journey through the stars, the silence, and the brilliant mind of a man who helped us see the cosmos more clearly, even when he could barely move a muscle. This is the story of Stephen Hawking, a scientist who spoke through a machine, but whose ideas echoed through space and time. We won't rush through facts or chase complicated equations. Instead, we'll drift softly through the places his mind explored: black holes, time, the edge of everything. You'll learn not just what Stephen discovered, but how he saw the world, and what he teaches us about resilience, curiosity, and the beauty of thought. So, get comfortable, let your breath slow, and allow the voice of the universe, his voice, to carry you gently into sleep. There is a certain kind of stillness that lives in childhood, not the stillness of sleep or of silence, but of quiet observation, the way a child might stare at a candle's flame, not to ask why it flickers, but simply to feel the wonder of it. Stephen William Hawking was born into such stillness on a cold January day in 1942 in Oxford, England. The world around him was uncertain, war-torn, rationed, reeling, but within his home, something different stirred. Books lined the shelves. Ideas floated in the air like dust caught in sunlight. His father studied tropical medicine. His mother had once considered becoming a scientist herself, but gave it up in a time when women were rarely encouraged to think that way. Stephen grew up surrounded by paperbacks and questions. At the dinner table, his family would read silently, each in their own world, yet together. It may have seemed odd to visitors, all those heads buried in books, but for Stephen, it felt like comfort. Words were windows, equations were stories, and science wasn't something far away. It was something that could live in your hands and in your heart. He wasn't a prodigy. He didn't speak particularly early or shine in a conventional way. In fact, some of his teachers considered him lazy or distracted. But Stephen noticed things. He asked questions that didn't always have answers. How did the universe begin? What existed before time? Why does anything exist at all? He didn't shout these questions. He whispered them, mostly to himself, sometimes to the stars. And perhaps that is how the biggest questions often arrive, not like thunder, but like dew. At school, Stephen was curious, mischievous, a little disorganized. His handwriting was nearly illegible, his room often messy. He was better at thinking than at following rules. But what he lacked in neatness, he made up for in imagination. One teacher later said, he was always asking deep questions. He wanted to know what made things tick. When he was 17, he entered University College, Oxford, to study physics. He found the coursework, at first, surprisingly easy. He didn't need many hours of study. He spent more time rowing with the college team, playing pranks, and making dry, clever jokes that often left his classmates blinking. There was a lightness to his early university days, as if life had not yet shown him its weight. But even then, his questions lingered. Gravity, motion, light, time. Why does the universe behave the way it does? Not just how, but why. Stephen was drawn toward the elegant, invisible forces that govern all things. He didn't want to memorize laws of physics. He wanted to understand them from the inside out. And yet, like all of us, he was still young, still unsure. In his third year at Oxford, He wavered between pursuing math and cosmology or applying his talents to something more practical. His father hoped he might follow in the family footsteps of medicine, but Stephen's compass pointed elsewhere, toward the skies. He once said, "I have always been deeply impressed by the rational beauty of the universe. The laws of nature may be complex, but they are not random. There is a pattern." That idea became a quiet rhythm in his thoughts, the belief that somewhere behind the stars and numbers, there was order. It wasn't until he began postgraduate work at Cambridge, studying cosmology, that the path began to unfold more clearly. He was stepping into the same university halls once walked by Newton and Darwin. He was no longer the boy wandering in the corner. He was becoming a man chasing answers. And yet, his curiosity never shouted. It never needed to. It moved with the rhythm of deep time, slow, deliberate, and steady. At 21, his life changed. Subtly at first. He began to trip. He struggled to hold a pen. His speech slurred slightly. At first, he ignored it. But soon the signs became louder than he could deny. A diagnosis arrived like a shadow. Amyotrophic lateral sclerosis, ALS. Motor neuron disease. A rare, progressive condition that would slowly take away control over his muscles, his limbs, his breath. Doctors gave him 2 years to live. It would have been easy, even understandable, for Stephen to give up the questions, to close the books, to fall inward. But something extraordinary happened instead. Faced with the boundaries of his body, he chose to stretch the boundaries of thought. He didn't know how long he had, but he knew what he wanted to do with it: understand the universe. In interviews much later, he would say that the diagnosis gave him focus. He could no longer waste time. Each breath became valuable. Each thought became vital. When one's expectations are reduced to zero, he said, one really appreciates everything one does have. And perhaps that is what made Stephen different. Not his intelligence alone, or even his resilience, but his reverence. He did not see science as a cold pursuit of facts. For him, it was a spiritual kind of wonder, a way of feeling at home in a vast, expanding cosmos. He began working with a mentor on his PhD thesis, focusing on the origins and structure of the universe, the very beginning of everything, the Big Bang. He was not only looking outward, into space, but inward, into time. As his body slowed, his mind became sharper, more precise, more determined. He started to imagine things that no one had fully seen before, singularities, places in space-time where the laws of physics break down. What happens at the center of a black hole? Could the universe itself have begun as a singularity? He wrestled with equations, with ideas that bent the mind into strange shapes. Time could curve, space could stretch, light could fall into a hole and never return. But he never stopped asking the oldest, softest questions. Why? What is this all for? How did it begin? The boy who had once stared at the stars from a quiet room in Oxford had now entered into conversation with the universe itself. And the universe, slowly, began to whisper back. He didn't do this alone. Along the way, there were friends, mentors, fellow scientists, and later, students who helped carry his thoughts into the world. His first wife, Jane, became a source of strength, belief, and care during those early years when his disease threatened to silence his work. Still, it was his questions, persistent, poetic, impossible, that carried him forward. not answers, not certainty. Questions. The ones we whisper when we are alone. The ones we ask when we stare into the dark and wonder how anything at all can exist. It is no small thing to ask a big question and wait in the stillness for the answer to arrive. And for Stephen Hawking, the next question became the heartbeat of his work, the one he would return to again and again. What is time, really? And can it bend? Time. For most children, time is something that slips between playtime and bedtime, between homework and holidays. It moves forward, one direction, one pace, like a train you ride without question. But for young Stephen Hawking, it was different. Time didn't just pass. It lingered in his mind like a question. Why does time move forward and never backward? Why did it begin at all? Why should anything begin and not just be? These were not the questions of a typical schoolboy. But Stephen was never typical. He was born on January 8th, 1942, exactly 300 years after the death of Galileo, into a family that prized books more than dinnerware, curiosity more than comfort. Their car was an old London taxi, their home cluttered with encyclopedias, and their dinner conversations often wandered into abstract ideas. While others chased after soccer balls or built forts in the garden, Stephen preferred building things that couldn't be touched. Theories, models, imaginary machines that lived inside his thoughts. Machines that moved through space, yes, but especially through time. At school, he wasn't top of his class, but his mind sparkled in other ways. He could take apart a clock and understand its gears without needing to see them. Time fascinated him, not in how to tell it, but in how it told everything else. Time was the great narrator of the universe, and Stephen wanted to read every line. He began to wonder, was time like a river? Did it flow smoothly from past to future? Or could it bend like a stream around a rock? Could it split in two? Could it possibly go backward? Physics, he learned, had its own ideas about time. Newton believed it was absolute, like a stage on which the universe played out, indifferent and unchanging. But Einstein had cracked that open. In Einstein's world, time was elastic. It could slow down or speed up depending on how fast you moved or how much gravity pressed around you. This wasn't just thrilling to Stephen. It was personal, because as Stephen moved deeper into science, something inside him began to change, slowly at first, like a shadow growing at dusk. He noticed he was clumsier than before. He stumbled when he walked. His fingers twitched. Words sometimes caught in his throat. Time, it seemed, was beginning to behave differently in his own body. Still, in those early school years, before the diagnosis, before the wheelchair, before the voice machine and the worldwide fame, Stephen was just a boy who dreamed in equations. He believed that buried within the rules of math were hidden the rules of time itself, and he wanted to find them. He would later say, "I want to know why the universe exists, why there is something rather than nothing." This wasn't ambition. It was hunger. In his teenage years, Stephen built a model computer out of telephone relays, alarm clock parts, and recycled switches. It could do basic math problems. But to Stephen, it was more than a gadget. It was proof that the physical world, even something as ghostly as time, could be tamed by understanding. He read about entropy, the tendency of things to move from order to disorder, like a cup shattering into pieces but never reassembling. Entropy, scientists believed, gave time its direction. The arrow of time pointed toward disorder, toward messiness, toward the future. That's why eggs don't unscramble. That's why we age. But could there be more than one arrow? What about the universe itself? Did it have a beginning? Would it have an end? He would carry these questions to Oxford University, where he began his studies in physics. At first, he found the classes easy, almost too easy. He didn't take notes, just listened, then imagined the material like a film running behind his eyes. He wasn't yet the man who would lecture with computerized voice and flashing eyes. He was a young student on a bicycle, darting through the city, thoughts racing even faster than the wheels beneath him. And yet, even then, something quietly ticked inside him, a different kind of clock. His movements grew slower. He began to fall for no reason. At 21, the diagnosis came: amyotrophic lateral sclerosis, ALS, a neurodegenerative disease. The doctors gave him 2, maybe 3 years. The future, that place he had dreamed of for so long, was suddenly shrinking. But here is the paradox of Stephen Hawking's life. As his body began to fail him, time did not slip away. Instead, it deepened. It opened. Faced with the possibility of no future, he became obsessed with the beginning of everything. He chose to study cosmology, the science of the universe as a whole, at a time when it was still considered speculative, even philosophical. But Stephen saw something others did not. The biggest questions often live in the smallest places. He began thinking about singularities, points in space where gravity becomes infinite, such as at the center of a black hole. But what if the universe itself had begun with such a point? What if time itself had a starting line, a moment not in time, but of time? He worked alongside mathematician Roger Penrose to explore this idea. Together, they proposed that the universe might have sprung from a singularity, not from emptiness, but from a place where the laws of physics, as we know them, simply break down. This was not just science. It was poetry and mathematics. It was a reimagining of the universe as something that could be understood, even if it was also infinite and mysterious. The irony is beautiful. A young man diagnosed with a terminal illness, obsessed with time, begins to explore how time itself might have been born. He studies how the cosmos might expand, contract, and curve around itself. He begins to see time not as a straight line, but as a tapestry, woven with gravity, with energy, with the deep breath of the Big Bang itself. And still, he wonders, what happens at the edge of time? Can we visit the past? Can we glimpse the future? Is time a road, a spiral, or a bubble? Could we build a time machine, not with gears and levers, but with understanding? Stephen never built a machine you could sit in, but he built something more lasting, a mental time machine, capable of traveling to the beginning of the universe and asking how it began. He would go on to explain how black holes might not be eternal prisons, and how the universe might have no boundary at all. But those discoveries come later. For now, in the stillness of thought, he sees time not as something slipping away, but as something you can learn to hold, to shape, to listen to. And in this quiet brilliance, a new idea begins to stir. If black holes swallow time and space, what happens inside one? What if they don't just consume? What if they also whisper? Soon, he will turn his attention to the darkest places in the universe, black holes, and wonder if, even there, time has secrets to share. There is a moment in every life when the ground shifts beneath your feet. And for Stephen Hawking, it happened quietly, cruelly, at the age of 21. He had been a student in motion, rowing on the river, cycling through Oxford's ancient streets, living with a mind sharpened by curiosity and a body still young, still full of promise. But then, the falling began. Not metaphorical, but real. His hands clumsier, his steps less sure. And soon, the diagnosis arrived like cold rain: amyotrophic lateral sclerosis, motor neuron disease. A few years to live, the doctors said. Maybe 2, maybe less. The body would fail, bit by bit, the nerves no longer carrying the signals that let muscle and motion dance together. It was a sentence without appeal, without treatment, without cure. For a while, he fell into silence. Imagine the mind, bright as a nova, trapped suddenly inside a vessel it cannot command. Imagine watching your own fingers and knowing, one day, they will no longer obey. Imagine knowing that time, which he loved to stretch and bend in thought, was now fixed and cruelly short. But even as his muscles began to still, his imagination accelerated. He once said that before the diagnosis, life had seemed boring, a bit pointless. A mind like his could devour so much so fast that he sometimes coasted, unchallenged, disengaged. But now, with the ticking clock made audible, everything sharpened. Every idea, every question, every star. He became, in a way, more alive. He began to think more seriously about cosmology, about the origin and fate of the universe, about black holes and singularities and the mysterious fabric of time itself. His thoughts stretched further than ever, even as his body narrowed its reach. And something extraordinary began to happen. He adapted. He began using his intellect the way a bird might use the wind, letting it carry him, steering with precision, even as the world below slipped out of reach. At Cambridge, he earned his PhD not with fanfare, but with fierce quiet. His doctoral thesis proposed that the universe began as a singularity, a single point, infinitely dense, where space and time themselves collapse into unity. It was a wild idea at the time, radical, almost poetic, and yet it would become one of the pillars of modern cosmology. His body had been given an expiration date, but his ideas had not. He refused to live small. With help from his first wife, Jane, who married him knowing what lay ahead, he carried on. She was a quiet force beside him, lifting the weight of daily life so he could float among the stars in thought. Every year, his body declined. Every year, his work deepened. He used walking sticks, then crutches, then a wheelchair. His speech began to slur, softening into whispers. But inside his mind, galaxies formed. Black holes evaporated. Time curled and uncurled like smoke. It was as if the universe, sensing his shrinking body, opened wider to his mind. His hands could no longer write equations, so he solved them in his head. Like a pianist who loses the ability to play, yet hears every note internally, Hawking rehearsed the rhythm of relativity and quantum theory in silence. He once claimed he could visualize an equation fully, turning it over, stretching it, compressing it, without ever writing it down. And so, while others measured distance by feet or miles, Stephen measured distance in thought. He became a traveler not through land, but through reality's edges. His voice, before the computer, was faint. Friends and students had to lean in close to catch his thoughts. But when he spoke, it was often with wit. Dry, sharp, and unexpected. Illness did not steal his humor. In fact, it seemed to sharpen it. He joked often about his condition, about his wheelchair, about death. He refused to become a tragic figure. Instead, he became something rarer, a symbol of intellectual freedom inside physical limitation. A man whose body folded inward even as his mind stretched outward. In interviews, he often spoke of life not as something to endure, but as something to explore, no matter how small the space you occupy. "I try to lead as normal a life as possible," he once said, "and not think about my condition or regret the things it prevents me from doing," which are not that many. Not that many. Even as his speech became unintelligible the most, he continued to teach. Students gathered not for what he could write on a blackboard, but for what he could spark inside them. He communicated through nods, through eye movements, later through a single cheek muscle and a voice synthesizer. Technology became his new voice. Robotic in tone, yes, but unmistakably human in meaning. And yet, he never chased pity. What he wanted was understanding. For the universe, for the laws of nature, for the beginning and the end. His story, by now, had become impossible to ignore. Not because he sought fame, but because his perseverance made the world listen. Books would come, fame would follow. But here, in the early days of his diagnosis, before the bestseller lists and documentaries and world tours, it was just a man in a wheelchair with a brilliant mind and a quiet defiance. In this stillness, something powerful was blooming. A deep cosmic voice, not loud, but clear. He would go on to question everything, from the origins of time to the fate of black holes. He would suggest that information, like light, can never be truly lost. He would peer into the heart of the void and hear it whisper. But first, he had to survive. And then, he had to think. This was not the story of a man dying. This was the story of a mind lifting off. A body slowed by gravity, but a mind caught in orbit, circling the edge of the unknowable, and refusing to fall. And as he sat in silence, surrounded by machines and books and thought, one question began to shimmer at the edge of his imagination. What if black holes weren't entirely black? What if, even in the darkest parts of space, something escapes? What if darkness isn't the end of the story at all? In the quiet stillness of his room, Stephen Hawking leans back, his body still, but his thoughts adrift in the darkness between the stars. Outside his window, the night sky is scattered with quiet lights, and somewhere among them, he knows, are objects stranger than anything imagined in fairy tales, black holes. Silent, invisible, all-consuming. The end of stars and the edge of time. Stephen begins to think not as most people do, in sentences and shapes, but in patterns, numbers, geometries that twist and fold. He sees the universe as fabric, not static, but trembling gently, warped where mass rests heavy. And when enough mass gathers into one place, that fabric buckles into a well so steep that not even light can climb back out. A black hole is born, but even as the world feared them, these cosmic monsters that devour everything, Stephen leaned closer. What happens, he wondered, at the edge of a black hole? The event horizon, that delicate, invisible border where escape becomes impossible. What laws of physics still hold there, and which ones break? Other scientists saw black holes as the final chapter, an end. But Stephen wasn't drawn to endings. He was drawn to beginnings, to questions that had no easy answers. And so he turned his attention toward the very place light disappears, hoping, perhaps, that something might shine back. With pen, paper, and a mind that moved faster than his body ever could, he began to calculate. He brought together the two great forces of the universe. Einstein's theory of general relativity, which described the large, stars, planets, the curves of space and time, and quantum mechanics, which spoke for the small, particles, uncertainties, the jitter of existence at the tiniest scales. For decades, these two pillars of physics stood apart, like instruments playing two different songs. But Stephen believed that at the edge of a black hole, they must meet. And in that collision, something new could be heard. In 1974, he proposed something radical. Black holes, he said, are not completely black. They glow, not with fire or light like a star, but with something subtler, stranger, a kind of heat. A whisper of radiation that slowly seeps from their edges. What became known as Hawking radiation. It was an idea that stunned the scientific world. Black holes were supposed to devour, but Hawking said they also give. The process, he explained, involved tiny particles appearing at the edge of the black hole. Virtual particles, flickering in and out of existence, as permitted by the rules of quantum physics. Normally, these particles come in pairs that cancel each other out. But at the edge of a black hole, sometimes one falls in while the other escapes. That escaping particle is what we see, the faintest ghost of light. The black hole, in giving off this radiation, loses energy. Over time, unimaginable spans of time, it could even shrink, evaporate, disappear. A thing thought to be eternal could fade. This was more than physics. It was poetry. From death, decay. From silence, sound. From darkness, a trace of light. Stephen's idea reshaped our understanding of black holes, and with it, of the universe itself. It suggested that information, the fundamental building block of everything, might not be lost, even in the deepest gravity well. That nature, somehow, remembers. Yet, it also sparked new puzzles. If a black hole evaporates, where does the information it consumed go? Is it lost forever? Or encoded somehow in the radiation it leaves behind? This became known as the black hole information paradox, a question still debated by physicists today. Stephen didn't mind the paradoxes. He welcomed them. They were the fingerprints of something deeper, a truth not yet seen, waiting behind the curtain. He often said, "If you feel you are in a black hole, don't give up. There's a way out." And perhaps he meant more than physics. Because black holes were not just objects to Stephen. They were metaphors. For illness. For isolation. For despair. He had lived inside one of his own. A body that failed him more each year. And yet, from that darkness, he sent out light. He radiated insight, humor, and wonder. He gave lectures through a computer voice that grew familiar to millions. He rolled onto stages in front of packed halls. He cracked jokes about the cosmos and about himself. He was, in many ways, the embodiment of Hawking radiation, light, escaping from the shadow. He made black holes popular, not scary, but fascinating. He pulled them from the far reaches of theoretical physics and placed them into bedtime stories, cartoons, and classroom conversations. He turned them into something almost human, strange, mysterious, but not beyond comprehension. And in doing so, he made the rest of the universe feel closer, too. He once wrote that a black hole has no hair. That is, it has no visible features. It tells you nothing about what fell inside. And yet, people began to wonder, could that really be true? Is everything lost in the fall, or do shadows remember? Even now, telescopes aim at the heart of galaxies, trying to glimpse what he imagined. The Event Horizon Telescope has given us images of glowing rings, light twisted by gravity, curved by time. It's as if the universe is whispering back to him, "You were right," or at least, "You were close." Stephen's theories may be tested for centuries to come, but already, he has changed something profound, the way we relate to the dark. In his hands, the void became a canvas, and so we drift gently with his thoughts into a place that once terrified us and now invites our curiosity. We learn that what disappears may not be lost, that even the smallest escape of light is enough to signal life, thought, and time. But there's still more to ask. What if we could describe the entire cosmos with a single expression? A formula that sings the laws of everything, from the gravity that cradles galaxies to the tiny dance of particles? Stephen believed we could, and that's where his gaze turns next. It begins, as always, with a question, not the kind shouted in lecture halls, but the kind whispered in the stillness between breaths. Why does the universe exist the way it does? Why these forces, these particles, this unfolding of space and time? Stephen Hawking lies in bed, the weight of his body growing heavier with each passing year. But his mind is afloat in galaxies. He is no longer trying to map just black holes or moments after the Big Bang. He is reaching for the grandest idea of all, a theory of everything. It sounds bold, audacious even, but to Hawking, it is an act of simplicity, not reduction, but revelation. Somewhere in the tangled web of quantum mechanics and general relativity, he believes, is a single thread that ties it all together. Imagine two great rivers of thought. One, the river of the small, quantum theory, which describes particles that flicker and dance, full of uncertainty. The other, the river of the large, Einstein's general relativity, where space bends and time stretches around massive stars and galaxies. Each river flows with truth, and yet, where they meet, in the heart of black holes, or the birth of the universe, they clash. Their waters don't mix. Stephen dreams of the bridge between them. The idea is not new. Einstein searched for it in the last years of his life, hoping to unify gravity and electromagnetism. He never succeeded. But Hawking, born just after Einstein's death, picks up the thread. Where Einstein worked with paper and pen, Stephen works in the language of pure thought. His hands can no longer hold a pencil, but his mind sketches across dimensions. He builds models in silence, folding time and space in his imagination, bending ideas like origami. The path is not easy. Physicists now understand four fundamental forces: gravity, electromagnetism, and the two nuclear forces, strong and weak. But gravity resists fitting in with the others. It curves space, it pulls without touching. It is geometry, not force. And so, theories emerge. String theory, M theory, quantum gravity, each a possible map of the unseen terrain. Each a different attempt to write the one equation that holds the universe in its balance. Stephen isn't just looking for mathematical elegance. He is looking for meaning. To him, a complete theory of the universe wouldn't just be for physicists. It would be a kind of shared poetry, something everyone could understand, not in formulas, but in feeling, like looking up at the stars and somehow sensing that you belong to their story. In his 1988 book, A Brief History of Time, he writes of this dream. The book, written in slow bursts through his computer's speech device, becomes a global phenomenon. Millions read it. Millions pause mid-sentence, not just to understand space-time, but to feel something vast and human within it. He writes, "If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God." He does not mean this in a religious sense. To Hawking, God is a metaphor for ultimate understanding, for the clarity that lies just beyond the horizon of what we can grasp. And yet, even as he chases this unity, Stephen is aware of mystery. He knows that science is not a finished painting, but a moving sky, always shifting, always incomplete. Even the most beautiful theory must survive the test of observation. Even the most elegant math must bow to the universe's stubborn facts. So he begins to ask, what if the laws of physics are not absolute, but shaped by the universe they describe? What if, instead of one history, the universe has many, like overlapping dreams, and we, through observation, choose the path we see? This leads him toward quantum cosmology, a field at the crossroads of physics and philosophy. He proposes something daring, that the universe has no boundary, no edge, no beginning point in time the way a road has a start. Like the surface of the earth, curved yet finite, time itself might be smooth and without edges. This no-boundary proposal is not easily visualized, but the metaphor helps. Imagine time not as a line, but as a globe, a soft, round shape with no hard corners. It changes everything about how we understand the beginning of everything. Stephen's work becomes a quiet symphony of possibilities. He is not promising final answers, but offering pathways, equations that sing softly about the deep order beneath all disorder. Each new idea is a step closer to something whole, something simple. His body weakens further. His speech, now entirely machine-generated, becomes the strange, iconic voice recognized around the world. But his message is clear. The universe is not chaotic. It is not meaningless. It is vast, yes, but not empty. It is written, perhaps, in one long, beautiful sentence. When Stephen lectures, audiences grow silent. Not because of pity, but because of awe. Here is a man who cannot move, cannot speak on his own, yet describes the birth of stars and the collapse of time as if reciting a bedtime story. He smiles when people ask if he thinks we'll find the theory of everything soon. Maybe, maybe not. He reminds them that even if we don't, the search itself is worthwhile. That wonder is not a destination. It is a direction. And so, night after night, he dreams not of escape, but of unity. Not of distant galaxies, but of simple truths. A single law, a single sentence, A single equation. Something quiet. Something elegant. Something like a whisper from the beginning of time itself. But even as he draws closer to that whisper, another paradox remains unresolved. One that has been with him since the early days, since chapter 4, the black hole. If black holes can leak radiation, as he proposed, where does the information go? Does the universe forget? Or is there, perhaps, a deeper memory hidden in its folds? One he has not yet uncovered? The wind whispers softly along the ancient stone corridors of Cambridge, brushing past the doors of the Department of Applied Mathematics and Theoretical Physics. These are the same halls once haunted by the quiet footsteps of Sir Isaac Newton, a man who reimagined the way we understand the heavens, who turned falling apples into revelations about gravity. Now, centuries later, another thinker enters these same halls, not with footsteps, but with wheels, not with parchment, but with a synthetic voice and a cosmic hunger. Stephen Hawking, in his wheelchair, does not follow in Newton's steps. He orbits on his own axis. It is 1979 when Hawking is appointed to the Lucasian Chair of Mathematics, the very position held by Newton over 300 years before. The world watches. A mind locked inside a failing body is now the occupant of the most storied chair in science. There is something beautiful in the symmetry. Two men separated by centuries, both drawn to the invisible. Newton gave us laws. Hawking gave us questions. From this chair, Stephen doesn't look down at the earth. He looks out, not merely toward planets or particles, but toward the beginning of everything. He dares to ask, what happens at the edge of time? Where does space begin and end, if at all? But this chapter isn't about equations alone. It's about resilience shaped into thought and dignity carried through circuits. As the disease advances, ALS takes more of Stephen's muscles, his arms, his legs, even the ability to speak. Yet his ideas only grow louder. His speech becomes a slow code, composed through a single cheek muscle and a blinking cursor. But somehow, the voice that emerges is stronger than ever. A mechanical timbre, clear and calm, begins to echo through lecture halls, conference rooms, and television screens. Stephen's wheelchair, once seen as a limitation, becomes a vessel, a spacecraft for the mind. He jokes often about his condition, disarming both pity and fear. He once said, "Although I cannot move and I have to speak through a computer, in my mind I am free." And truly, he is. In that mind, he plays with quantum particles like marbles on a floor of space-time. He watches black holes dance with entropy. He imagines the universe folding and unfolding like a breathing organism. Inside that wheelchair is not a man retreating from life. He is a beacon, rolling into schools, science festivals, late-night talk shows, and even Star Trek sets. He shares physics not as a locked-away scholar, but as a companion to anyone willing to listen. He believes that science belongs not just to scientists, but to humanity. That understanding the stars makes us better at being human. And this, perhaps, is the most revolutionary thing about Hawking. His accessibility, not just in terms of disability, but in terms of his ideas. His most famous book, A Brief History of Time, becomes a global phenomenon. Millions of copies sold. A science book that becomes a bedside book. People from all walks of life hold it in their hands. Some reading every word, some reading just a few pages. but all touched by the same message. The universe is yours to understand. From the Lucasian chair, Stephen doesn't just explore black holes or the Big Bang. He creates a language of invitation. His theories are gifts wrapped in metaphor. He speaks of singularities as places where all the laws of physics break down. But he delivers these concepts like stories. Campfire tales told beneath the stars. He compares the universe to a no-boundary surface, like Earth, which has no edge, only curvature. He says time might behave like space, curving, folding, beginning without beginning. These ideas are not easy, but in his hands, they become music. Cambridge grows used to the quiet hum of his chair down the corridors. Students pass him with wide eyes. Some say it feels like seeing a living constellation. He lectures not only to physicists, but to children, to poets, to heads of state. And always, beneath the mathematics, is something deeper, a soft insistence that life is worth the thinking, that even as our bodies fail, our wonder can grow wings. There's a photograph that often circulates. Stephen, in his chair, beneath the vaulted ceiling of a grand hall, Newton's portrait hanging above him, two figures staring into infinity, one with an apple, the other with a singularity. But Hawking never seeks to replace Newton. He expands the orbit. He shows that greatness in science is not just about genius, but about endurance, curiosity, courage wrapped in formulas. And so, the wheelchair becomes a throne, not a symbol of limitation, but of power, a quiet, persistent power that rolls forward, through time, through loss, through gravity itself. What Newton once revealed through motion, Stephen reimagines through stillness. And even now, long after he has left that chair, his ideas remain seated in the minds of millions, spinning, expanding, glowing like distant galaxies. Because sometimes, the ones who cannot walk are the ones who help us travel the farthest. And yet, even in all this brilliance, Stephen never lets go of one strange question. Why do black holes glow? Why does something that swallows light still whisper? In the next breath of his journey, he leans closer to the edge of the dark and listens. There is a stillness that enters the room when a voice fades. A hush, not of absence, but of transformation. When Stephen Hawking could no longer speak with his own vocal cords, many thought the silence would grow heavier. But instead, it became something else, something astonishing. In this silence, he did not disappear. He did not retreat. He found a new way to be heard, not in spite of the silence, but through it. It began with a small, synthetic tone. A machine, no larger than a calculator, offered him a bridge between thought and sound. With the movement of a single muscle in his cheek, he selected words, one by one, thought by thought, slowly at first, then more surely, until sentences formed, crisp, robotic, unmistakably his. The voice, flat, American, and oddly mechanical, became iconic. It wasn't natural, but it was deeply human, because every sentence spoken this way was a miracle of persistence, a declaration that thought still lived, still moved, even when the body could not. Stephen's words weren't just brilliant, they were deliberate, carefully chosen, patiently constructed, each one a miniature act of triumph. Imagine waiting minutes to form a sentence and still having the will to do so again and again for decades. In that patience lived both discipline and grace. His was a voice born not of breath, but of will. And this will carried him far beyond the world of science journals. It carried him into the hearts of millions. His ideas no longer lived only in academic halls. They traveled to classrooms, television screens, documentaries, and late-night talk shows. He became a household name, not because he sought fame, but because he embodied resilience. He made black holes understandable. He made the universe feel close. And he did it all with a voice that was once nearly lost. There's something mesmerizing about listening to his robotic tone, steady, slightly monotone, yet full of warmth in its meaning. It was not a limitation. It was a style, a signature, as recognizable as a familiar melody. When asked if he'd ever switch to a more natural-sounding voice, he declined. "My voice," he said, "has become part of my identity." That voice, that calm, synthetic voice, reminded the world that brilliance doesn't need to shout to be heard. His voice narrated A Brief History of Time, a book that sold over 25 million copies and stretched minds across the globe. In it, he pondered time, space, beginnings, and ends, all in language so simple that it felt like poetry. Even if you didn't grasp the math, you felt the mystery. That was his gift. He believed that ideas should not be locked behind equations. They should be shared like stories, stories that belong to all of us. Stories that began at the Big Bang and echoed into the future. This belief brought him to stages and screens, to interviews and animations, and even to shows like The Simpsons and Star Trek. He was not afraid to laugh at himself or at the universe. He once said, "Life would be tragic if it weren't funny." And in his voice, humor became another kind of science, a way to connect. He joked about time travel, about aliens, about throwing parties for people from the future. And through it all, his robotic voice somehow made the jokes even funnier, like the universe itself was playing along. But behind the jokes, behind the equations, was a man who refused to be defined by limitations. A man who, while bound to a wheelchair and unable to move, still shaped the way we understand existence. He once compared himself to a computer, not out of cynicism, but out of fascination. The brain, he believed, was a processor of extraordinary complexity. And though his physical hardware had begun to fail him, his mental software was constantly updating. This metaphor, too, became part of his legacy, that consciousness is not housed in limbs or lungs, but in the patterns of thought that ripple across the mind like stars forming in space. And in this understanding, there was a kind of peace, a quiet affirmation that identity lives in what we imagine, what we say, and what we choose to believe. He chose to believe in communication, even when it seemed nearly impossible. He chose to write, to teach, to speak. With a single twitch of the cheek, he painted entire universes. And others helped him speak. Engineers, nurses, speech therapists, all became part of the orchestra that supported his voice. But the melody? The melody was always his. There's something beautifully paradoxical about it. The more his body faded, the louder his voice seemed to grow, not just in volume, but in meaning, in clarity, in reach. And what did he use that voice for? Not for complaint, not for anger, but for teaching, for warning, for dreaming, for laughing. He used it to talk about the fate of the cosmos, and the threat of climate change, and the future of artificial intelligence. And always, about the power of the human spirit. He reminded us that we are all temporary, fragile, bound by time, but that in knowing this, we become something greater. We become aware. We become curious. We become kind. When asked what kept him going, he replied simply, "Where there's life, there's hope." And in that hope, his voice continues. In classrooms, his words are still taught. In homes, his books still rest beside lamps. In podcasts and YouTube videos, his phrases still loop through speakers. In minds, his ideas still bloom, quietly, endlessly, like galaxies expanding. It is easy to think that a man so brilliant must have lived in a world apart. But Stephen lived in our world. He faced traffic, deadlines, frustration, doubt. He fell in love. He raised children. He argued. He danced, in his own way, with life. And always, he spoke, even through silence. Tonight, as you lie back and close your eyes, think of the voice that found its way through silence and steel. Think of how words, when chosen with care, can travel across time. Think of how a whisper can echo louder than a shout when spoken from the depths of truth. And just beyond the edge of that voice, beyond its calm, deliberate tone, comes the faint sound of laughter, of parties no one came to, of paradoxes and jokes about time travel. Because the voice that spoke through silence was not only brilliant, it was curious and playful and always ready to wonder what came next. The clock ticks, always forward, never back. That's what we believe, isn't it? That time is a river, flowing only one way, carrying all things from birth to end, from start to stop. But Stephen Hawking, ever the gentle mischief maker, wasn't so sure. Or at least, he didn't want to take time's word for it. He wanted to test the river, maybe even throw a pebble upstream and watch the ripples form before they were thrown. One quiet day in 2009, with no cameras, no guests, and no RSVP list, Stephen Hawking hosted a party. A real one. Balloons, hors d'oeuvres, chilled champagne, elegant place settings, a large sign welcoming visitors to the reception. He sat alone in the decorated hall, waiting, but there was one catch. The invitations were sent after the party ended, days later, publicized only afterward. If time travelers were real and the laws of physics allowed, someone, anyone, might arrive before the announcement. A mysterious visitor stepping through some invisible fold, claiming a chair, raising a glass. But no one came. Stephen, of course, was not surprised, nor was he disappointed. The party was a paradox, yes, but also a punchline. A quiet laugh folded inside a deep question. What better way to find out, he later said, than to invite them? It's the kind of thing he loved to do, play with the universe's rules like a child testing gravity by dropping apples. Only his apples were thoughts. His gravity was time itself. Time travel. It stirs up wild dreams, books, movies, fears, and hopes. But for Stephen, it wasn't fantasy. It was physics. A serious question with serious math, cloaked in charm. And beneath the jokes, there was always the science. We often think of time as fixed, absolute, a shared, universal heartbeat. But that's not what the universe says. According to Einstein, time is elastic. It bends. It stretches. It slows down when you move faster or when you're near a massive object like a star or a black hole. This is time dilation, a real, measured phenomenon. Astronauts who spend long periods in orbit age a tiny bit less than those on Earth. It's small, fractions of seconds, but real. Stephen took that knowledge seriously. If time can stretch, can it fold? Can it loop? Could we, even in theory, visit the past? That was the question he poked and prodded, not with fiction, but with formulas. One of his deepest fascinations was with closed time-like curves, solutions to Einstein's equations that allow for a path through space-time which loops back on itself. Think of a tunnel in time, a wormhole, perhaps, that lets someone return to an earlier moment, like stepping through a door and finding yourself in yesterday. It sounds magical, but Stephen always asked, what stops the paradox? What keeps someone from going back and preventing their own birth? Or inventing something before it's invented? Or attending a party that hasn't been announced yet? That's where his serious thinking met a wall, or perhaps a guardrail. Stephen proposed the chronology protection conjecture, a kind of cosmic safeguard. A rule built into the fabric of reality that prevents time travel into the past. Not because it's morally wrong, but because the laws of physics might not allow it. He believed that as soon as a time machine could be created, energy fluctuations or quantum instability would destroy it. The universe, it seemed, didn't want its story rewritten. Still, that didn't stop him from wondering, or from smiling at the edge of the impossible. Stephen had a special way of blending the playful with the profound. He could move from the equations of general relativity to the set of The Simpsons, where he voiced a cartoon version of himself. Cape, wheelchair, and all. He loved humor, not as escape, but as a doorway into deeper thought. Because sometimes, laughter is a way to explore what logic cannot. His party for time travelers was more than a joke. It was an invitation to question what we believe about the world, not through textbooks, but through imagination. Could time really flow backward? Would anyone ever find a way? And if they did, what would they change? Stephen often reminded us that time has a beginning and perhaps an end, that it's not just a stage on which the universe plays, but a character in the story itself. Time grows, warps, and dances with gravity. It curves around stars and collapses inside black holes. It expands as the universe expands. It may have once been compressed into a single point, like the heart of a fire waiting to explode. And though we live our lives minute by minute, Stephen lived much of his life beyond that rhythm. His mind leaped ahead, explored centuries in theory, touched the origins of time and the end of black holes. He played with pasts that couldn't be changed and futures that hadn't yet arrived. And perhaps, sitting at that empty table in 2009, Stephen didn't expect anyone to show up, but he hoped someone might. Not because he believed it, but because he loved the thrill of asking, what if? Because what if is the first step of science, and of dreaming, and of hope. And so, the party ended. The champagne warmed. The clock ticked on. No one came, but something about it lingered, that empty room full of possibilities, that gentle dare to the universe, that quiet moment where science and humor held hands, and the question remained suspended in time. Stephen showed us that curiosity isn't always loud. Sometimes it's a soft whisper sent into the unknown, a question written in the stars, a chair waiting to be filled, an invitation unanswered, not because it failed, but because it dared to hope. Time may not loop for us, but minds like Stephen's, they echo. They ripple through generations, through science and stories, through paradox and poetry. And even now, long after the party has ended, we still wonder, if light can't escape a black hole, how did his ideas shine so far beyond one? And that, gently, quietly, leads us to the final horizon. As the world spins on, the quiet within Stephen Hawking grows deeper. His breath shortens. His hands no longer move. His voice, once aided by a soft machine, becomes less frequent and then still. But even in the soft hush of his final years, his mind continues its long orbit, around black holes, around the origin of time, around the grand mystery that called to him since childhood. He is no longer a man of movement, but a man of motion, the motion of thought, of imagination, of cosmic reach. His body may slow, but the universe continues to open for him, like a dark sky blooming with stars. His wheelchair becomes his vessel, his telescope, his ship. With it, he sails. There is something both silent and roaring about the final horizon. Hawking spoke often of event horizons, the edges of black holes, the point beyond which no light can return. But he never feared them. He understood them as places not of endings, but of unseen beginnings. Beyond the horizon, things may fall away, but they do not disappear. They change. That, perhaps, is how he began to see himself, not fading, but transforming. In the evenings, when the Cambridge sky darkened and the world slipped into a hush, Stephen would still write. With his cheek muscle and a single button, he composed words that moved millions. His papers became rarer, his talks more precious. Each thought was a distillation, like starlight that had traveled a long, patient distance to reach us. Even as ALS took nearly every voluntary muscle from him, he remained devoted to understanding the involuntary ones of the universe: gravity, entropy, time. He laughed often. He welcomed visitors with warmth. He played games with his children, attended conferences, debated boldly. He loved. The man who once feared he wouldn't live past 25 had become an elder of the stars. Every breath was borrowed time, and he spent it not in mourning, but in motion. His room became a kind of observatory. While others stared through telescopes at galaxies, he stared inward, through equations, through models, through questions that had no clear answers. He contemplated the singularity, the point at which physics breaks down, and with it, perhaps, the mystery of death. He often said that science would not just explain the universe, but might give us a reason to feel at home in it. His final years were spent working on what he called the no-boundary proposal, an idea that the universe may not have had a singular, defined beginning. That time itself could be curved, like the surface of the earth, with no sharp edges or moments of origin. Just as you can walk around the globe without falling off an edge, perhaps time too was self-contained. This idea was not just scientific. It was spiritual in its own quiet way. It offered a comfort that aligned with Hawking's deepest belief, that the universe is knowable, and that in knowing it, we find peace. He once said, "However difficult life may seem, there is always something you can do and succeed at. It matters that you don't just give up." And so he didn't. Not through pain, not through stillness, not through the slow letting go of his physical world. As his condition progressed, and the fragility of his body became more evident, his thoughts became even more expansive. He theorized about the multiverse. He imagined civilizations far beyond Earth. He warned about artificial intelligence and celebrated scientific collaboration across nations. His mind, once fixated on the dense mathematics of black holes, now seemed to float gently through the wide, open field of future possibility. He remained a voice, not just a scientific one, but a human one, a reminder that intellect is not tied to physical strength, that will can transcend bone and muscle, that curiosity can become a form of courage. Stephen lived to the age of 76, passing on March 14th, Pi Day, and the birthday of Albert Einstein. A poetic coincidence, one might say, but perhaps the universe, too, has a sense of rhythm. After his passing, black holes were imaged for the first time. Space-time became a phrase known in classrooms around the world, and his books remained on shelves and bedsides, pages still turning. He requested that his ashes be buried in Westminster Abbey, between Sir Isaac Newton and Charles Darwin. There, beneath a stone etched with one of his most famous equations, the formula for Hawking radiation, rests a man who lived in the spaces between the stars. But Stephen Hawking never truly belonged to the ground. He belonged to orbit, to curvature, to the dance between light and time. And perhaps, as his final breath slipped gently from his lungs, he crossed his own event horizon, not vanishing, but continuing into memory, into legacy, into the very fabric of space he loved so deeply. He once asked, "What is it that breathes fire into the equations and makes a universe for them to describe?" He never claimed to know the answer, but maybe, in the final hush, he came a little closer. And now, as we close our eyes with him, we are not stepping into darkness, but into the mystery that follows light. We lie quietly, wondering, if he is gone, why do we still feel him in the stars? Why do we still hear a voice that speaks, even through silence? Why do we still ask questions, as if some part of him is still listening? There is no statue tall enough, no monument wide enough, to contain the mind of Stephen Hawking. And yet, as the stars shine quietly overhead, his legacy feels as though it is written across the sky itself, not carved in stone, but in light, in thought, in the simple act of wondering. You lie still now, breathing slowly, the world dimming around you like twilight. In this quiet space, something of Hawking's voice lingers, not his computer-generated words, but the rhythm of his thinking, the grace of his imagination. He did not seek to be remembered with loud applause or thunderous fame. What he left behind was quieter, more like a ripple across a still pond, traveling outward through generations of minds. A momentum, not a monument. A gentle insistence that asking questions is more powerful than having all the answers. Hawking's final years were filled with speeches, books, and broadcasts. Even as his body became more fragile, his vision expanded. He co-authored theories about the multiverse, the idea that our universe may be one of many. He spoke often about humanity's future, warning of climate change, artificial intelligence, and the need to look to the stars not just for wonder, but for survival. His mind, once described as one of the most brilliant since Einstein, continued to dance with paradoxes. Black holes, entropy, the arrow of time. He brought these concepts down from academic towers and placed them gently in our hands, in children's books, documentaries, and public talks. He wanted us all to see what he saw, a universe full of strangeness, but also of beauty. And yet, for all his brilliance, it was not only his intellect that moved people, it was his resilience, his wit, the way he could turn misfortune into momentum. Diagnosed with ALS at 21 and told he might only have a few years to live, he lived more than 50 beyond that, a full life that defied the curve of expectation. He once said, "My expectations were reduced to zero when I was 21. Everything since then has been a bonus." And perhaps that is why he saw the world differently. Where others saw limits, he saw possibility. Where others saw endings, he saw beginnings. His life became a story not of tragedy, but of transformation. Even his wheelchair, that constant symbol of his condition, became, in time, a vessel, not of confinement, but of motion. It carried him across continents, into schools, onto stages, into films, and even animated cartoons. He became a pop culture icon not by abandoning science, but by embracing the joy in sharing it. He had humor, sharp as a comet. He once joked, "Life would be tragic if it weren't funny." And in that balance, between gravity and levity, he walked his tightrope with grace. But beneath it all was always the science, the search, the profound need to understand. He often spoke of the cosmos not with detachment, but with awe. He saw the universe as something precious, and ourselves as part of that preciousness. We are just an advanced breed of monkeys on a minor planet of a very average star, he said. But we can understand the universe. That makes us something very special. To understand. That was his calling. And it's what he offers to us. Not just facts or formulas, but the spark of curiosity. A permission, even an invitation, to wonder. You can almost hear it now. Not a voice, but a feeling. A whisper across the fabric of night. A soft question, not spoken but known. What else is out there? The sky outside might be dark, but for Hawking, darkness was never emptiness. It was potential. It was a canvas waiting to be explored, drawn with gravity and dust, stars and silence. In the grand scheme of things, Stephen Hawking was a blink, a brief moment in cosmic time. And yet, within that moment, he touched eternity. He taught us that science does not strip life of meaning, it deepens it. He showed us that black holes are not entirely black, that silence can be eloquent, and that even a body bound to a chair can explore the edges of the universe. He helped us see that the universe is not a cold machine, but a living story, a poem of physics, a melody of mathematics, a conversation still unfolding. And now, as you rest, you carry a piece of that story. You are not separate from the stars. You are made of the same dust, spun from the same atoms, shaped by the same forces. Stephen Hawking is no longer here to speak, but the questions he asked, they remain. They rise with the sun. They ripple through school books and satellites, through classrooms and coffee shops, through the hush of museums and the wild noise of playgrounds. They live in every child who looks up and wonders why the sky is blue, in every person who stares into the night and feels both small and vast. We are all made to wonder, and maybe that's the quiet truth he left behind, that curiosity is not just a path to knowledge, but to meaning, that to ask is to become fully alive, that to imagine is to belong. And so, as you close your eyes tonight, know that you are not drifting away, but falling inward, into a universe that welcomes questions, a cosmos that pulses with mystery, a reality still unfolding. Your breath slows, the stars hum softly, and the next great question rises, quietly, just ahead. What if time is not a line, but a loop? What if beginnings are never really endings at all? And now, the voice fades, not in silence, but in stillness, like the last vibration of a bell, gently ringing out into the dark. Stephen Hawking is no longer among us in body, but his thoughts move like constellations, across the skies of our minds, not fixed, always unfolding, always becoming. He showed us that even when the body weakens, the mind can fly, that the universe, so vast, so cold, so ancient, can feel close, warm, and deeply human. He taught us not just equations, but the courage to keep asking why. Not just black holes and time warps, but how to hold on when gravity pulls hardest. Tonight, beneath the dome of stars, you rest where he once dreamed. Your breath is quiet, like the background hum of the cosmos, and the questions he left behind gather softly around you, not to trouble you, but to keep you company. There will always be mysteries, but thanks to him, we know mystery isn't the enemy of peace. It's the birthplace of wonder. So sleep now, not as someone left behind, but as part of the story still unfolding. The atoms in your bones once lived in stars. The questions in your heart belong to the cosmos. You are not separate from the universe. You are what the universe asks, when it dares to wonder about itself. And somewhere, in that great silence beyond sound, perhaps the voice of Stephen Hawking still echoes, not in words, but in every mind that dares to dream. Good night, and keep wondering.